Right here, folks. So in chapter 15, we've been looking at exponential, logistic, and logarithmic functions. On 15.1 and 15.2, we talked in pretty good depth about exponential and logistic functions. In 15.3 and 15.4, we're going to talk about logarithmic functions. I'm going to start that discussion here today in 15.3. Sure. So I'm going to start with the definition of a logarithm. So if we have some exponential equation, b to the y is equal to x, that is equivalent to the logarithmic equation, log base b of x is equal to y. So what is this logarithm? It's the exponent that satisfies an exponential equation. So like what power of 2 is equal to 3? Well, it's going to be log base 2 of 3. That's the name we're going to give to that number. Is everybody okay with this idea? So if I have these two equations and I have b to the y is equal to x, and then y is equal to log base b of x, if I go and I plug that in, where I've taken this and put it in here for y, I have that, right? So what's going to happen here is that exponent base b and log base b cancel out, and we're left with x is equal to x. If I made a similar substitution and I know b to the y is equal to x and I drop that into the x over here, we can say that log base b of b to the y is equal to y. And then like log base b is going to cancel exponent base b. We have that y is equal to y. What is this saying here? What? Close. It's wrong I word though, not identity, but inverse. So what we're saying is that exponential and logarithmic functions are inverse of each other, just like addition and subtraction are inverse operations, or multiplication and division are inverse operations, or the square root and the power of 2 are inverse operations, or cosine and cosine inverse are inverse operations. That one of them is going to cancel the other one out. Okay? That's why they're so frequently paired together. When you learn one, you learn the other right afterward, because they are inverse operation. So let's do a little practice of using this definition of a logarithm to recast our logarithmic problem into an exponential. So let's say we have log base 4 of 16. So I'm going to think about the answer as y. That gives us a logarithmic equation just like I have up here. Everybody's okay with that? If I look at that, I say, okay, well, the b is 4, the x is 16, and then y is just going to be y, right? If I use my definition of a logarithm, I can rewrite that as the exponential equation. 4 to the y is equal to 16. Oh, well, what power of 4 is equal to 16? 2. Is everybody okay about how I use that definition of logarithm to rewrite my logarithmic equation as an exponential? Okay, let's do that again then. So this time we have log base 5 of square root 5. Again, I'm going to write it as y equal to y. So I have a logarithmic equation. I'm going to identify the values for b, x, and y, and then rewrite this as a exponential equation and ask what power of 5 is equal to the square root of 5. One half is correct. How'd you get that, Luco? Yeah, Luco remembers this property of exponents was what he used there to say that. Because there's an index of 2 on a square root and a power of 1 on the 5 that are there, but we don't need to write down. We understand them to just be there. Okay. What if we have log base 12 of 1? Well, we'll write it as an equation. Identify the b, the x, and the y, and then rewrite this as a exponential equation. What power of 12 is equal to 1? 0 is correct. How'd you get that, Alex? Anything to the 0 power is 1 other than 0, right? 0 to the 0 is undefined. Okay. And our last example here, again, we write it equal to y to make an equation. Write down our values for b, x, and y. Translate that to an exponential equation and ask ourselves what power of 8 is equal to 8 to the first. Yeah. Is everybody okay on how we're using the definition of a logarithm to rewrite these logarithms as exponential equations that are usually a little bit easier to solve, or at least in some cases can be really easy to solve? What I want to do now is I want to take these ideas that we just saw and summarize them into some rules that will work for logs of any base. So if I take log of any base and I evaluate 1, that's just going to be 0, right? If I do log base b of b, that's always going to be 1. Everybody's okay there with the bases or the b's match? And then as we started, log base b of b to the x, well, the log cancels the exponent base and leaves us just with the exponent. So that should just be x. Or b to the log base b of x power. Again, the exponent base cancels the logarithm, and we're left with just the x there as well. What do you guys think? It's okay? Okay. So some notation. There are 2 special values of b that we give a name to. So when b is equal to 10, we call log base 10 the common logarithm, and we abbreviate it just as log. We don't write any subscript. Okay? Just like when we write a square root, we don't write index 2 in the square root. That one we use all the time. We just recognize it to be square root or index 2 even though we don't write it. Same idea here. There's a log you'd use all the time, so we're not going to bother to write the 10 there. We're just going to understand that it's there. Is everybody okay with that? So instead of writing log base 10, we just write log. The other special value for b is when b is equal to e. We call that the natural logarithm, and we abbreviate log base e with the letters ln. So I always write my ln cursive because a lowercase letter l looks too much like the number 1, and that feels like it gets confusing, so I always write it as ln with a cursive l and n. Why the letters ln? Because the mathematicians that kind of formalized this notation were French, and ln stands for like logarithm de naturel or whatever in French. So there you go. All right, so let's do some examples here using these notations. So I have log of 1,000. What base is log of 1,000 going to be? Base 10. Remember, there's a 10 there that we don't write. So if I set that equal to y, I have now a logarithmic equation that I could translate into an exponential equation. And I ask myself, what power of 10 is equal to 1,000? 3. Because 10 times 10 is 100, and times 10 more is 1,000. So that's 10 to the third, right? 3 times multiplied together. So, okay?
Purpose of logs. And why do they exist? Like, use the exponential equation?
Because not everything is going to be so convenient to write the exponential equation and see what the answer is. We'll see in a couple of days. Yes, sir. Yep. All right. Here we have log of, oh, hey, also, if you look at your calculator, let's do this right now. If I look at log of 1,000, I can do that on my calculator. Notice on the left side of your calculator, there's a log button. That is the common log button. So I can just type in log of 1,000 in my calculator and look, boom, there the 3 pops right out for us. Everybody cool there? Okay. If I have log of 0.01, what is the base of that logarithm? 10. So I'll make that a logarithmic equation. Identify my b, x, and y. I can recast that now as an exponential equation. What power of 10 is 0.01? Close. Think about 0.01 as the fraction, 1 over 100. So it should be -2. I need the negative sign to make the fraction, and the 2 for 10 squared to be 100. And again, if you wanted to on your calculator, we could type log 0.01 and press enter, and boom, -2 pops right out for us. Okay. What if we have some solving equations here?
Wouldn't it just be like whenever we don't with apply,
Well, let's look at this one. We have an ln here, right? What is ln the same as? Log base e. And now notice that we have exponent base e and log base e. What's going to happen with those two guys? They cancel out. And what are we just left with? That d is equal to 5. And we're done. Is everybody okay there? Okay. So in part, or no, example B here, we have 2 is equal to log of x. What base is that logarithm? Okay, so log base 10 of x. So if I want to get that x by itself, I need to cancel off the log base 10 there, right? What's going to cancel out a log base 10? What operation cancels a logarithm? An exponential. What base for my exponential should I choose? 10, because it should match the base of my logarithm. So I'm going to write a comically big exponent base 10 to emphasize that we're not multiplying. Exponent base cancels log base, and 10 squared is 100. That's equal to x. Is everybody okay with that? Okay, alternatively, you could have thought about this as the exponential equation. 10 squared is equal to x, and you get the same thing. Right? Either way of doing it is fine. I like to introduce these multiple methods because depending on what you're doing, you may want to choose one way of thinking about this or the other. They're both equivalent. They're going to do the same thing, but like in an actual problem, one way may be a lot more convenient than the other. All right. Next example, we have ln of y is equal to 5. What does ln mean? That's right. Log base e of y is equal to 5. And what's going to cancel out that log base e? Exponent base e. Again, I'll write a comically big exponent base. Just to emphasize that we're not multiplying here. That's the most common misconception students make when they go back and look at their notes. They mistake an exponent base for multiplication. So I have then y is equal to e to the 5th. And if I want, I can go to my calculator. And you notice above the ln button is a e to the power. I can type e to the 5th, and I can say that answer is about 148.4. Max, what's up? What's up? Yeah, go ahead. So far, so good. Let's keep rolling. Here, we're just going to use our calculator to practice evaluating these things. So again, if I want to do log of 51.37, I just use the log button on my calculator, 51.37. Bam, answer, done. Is everybody okay with that? If I want to do the natural log of 12, if I look up below the log button on my calculator is the ln button. So I do ln of 12. Type it in, bam, done. 2.48. So far, so good. If I want to do log base 2 of 3 on my calculator, well, I look here and there's no log base button where I can type in a base that I want. To get that, I'm going to press the math button. And I'm going to scroll down and look for the command called log base. There's mine, Command A. And then I can just type it in exactly like it looks on my sheet of paper and press enter. So log base 2 of 3 is 1.58. What do you guys think? And so that's how to type logarithms into your calculator. Your assignment for this is going to be 37 to 68. Most of it's just like the examples we've done, where either you're typing in your calculator, or you're just recasting it as an exponential and looking at it and like, oh, 2, oh, -1, oh, 1/3, you know, where it's like usually pretty simple. That's it for today. How do you guys feel on this stuff?
So do we have problem sets due on the Sunday?
So this problem set we'll have due for the weekend after.
Okay.
So just have the 2 for Sunday. So I think that's 1 through 36 total. Okie dokes, artichokes.